State University of Oil and Gas, and my subject in my team is construction optimization study for cargo containment system of Arctic LNG carriers. Arctic and subarctic regions of Russia have large reservoirs of natural gas, and natural gas may be exported from these regions using different variants, but one of them shipborne transportation system. In this case, we have to assess the integrity and safety of a cargo containment system under repeated ice impact. You know what is the LNG? LNG is liquefied natural gas. LNG is natural gas that has been cooled and condensed to a liquid. At atmospheric pressure, LNG has temperature about minus 160 degrees. 1 cubic meter of LNG corresponds to 600 meters natural gas. LNG is colorless, odorless, non-corrosive, and non-toxic. And other parameters you can see on the slide. Various cargo containment systems having various structures, materials, having various configurations have been proposed and put into practical use. Most containment systems, the spherical system and membrane containment system, are adopted mainly at present due to the economy and reliability. Spherical containment system and these tanks and hull are independent system. Tanks are arranged into the hull, and therefore thermal deformation due to the expansion and contraction isn't directly conveyed to the hull. For membrane containment system, concept is based on a primary thin invar layer which is supported through the insulation. Membrane containment system must always be provided with a secondary barrier to ensure the integrity of total system in the event of primary barrier leakage. Here you can see spherical type of containment system, vessel. There are some advantages, disadvantages of each of system. For spherical LNG cargo tanks, advantage is independent from ship hull. Stresses from the hull not transferred into the cargo tanks. Very robust design, no sloshing problems, can operate with partly filled tanks, and allow simultaneous building of hull and cargo tanks. Disadvantage: low volumetric utilization of the hull, larger physical dimensions for the same, and visibility is not so good if we compare membrane and spherical tanks. For membrane containment system, advantage is a high volumetric utilization of ship's hull, less sensitivity to temperature change as invar membrane, invar steel, has very low thermal contraction coefficient, and limited need for heel on ballast voyage. A disadvantage: cargo tanks are integrated as a part of the hull, as a part of the vessel, doesn't allow simultaneous construction of hull and cargo tanks, and restricted filling radius. In our work, we have calculated the GTD number 96 system, the membrane containment system. This is, you can see, your standard criteria. The first A, the invar membrane strake, is the primary barrier. This barrier is attached to the perlite filled plywood boxes. Is the primary insulation. They are in turn attached onto an identical invar layer with the secondary barrier, and finally further set of similar perlite filled boxes, plywood boxes, used as a secondary barrier. Problem sloshing. Since LNG has all properties of the liquid, sufficient attention should be given to an effect of free surface water and influence of this water on the vessel stability. Moreover, hydrodynamic impact can lead to destruction of the tank, impose devising mechanisms inside, due to incomplete filling of the tank and large free surface of the liquid. If we discuss about transportation in Arctic conditions, you can see on the picture movement of the vessel. We have not ice breaking supporting vessel, have to break ice with moving rope, go forward, go back, and in this case we have large motions of the liquid in case of incomplete filling of the tanks. You can see results of the sloshing in the tanks here. Destroyed membrane, primary membrane, and insulation boxes extracted from the tank. And these results and the open water conditions, but we have no exploitation. We have no experience of exploitation in Arctic conditions. Maybe we will have most problems. In our work, we have calculated different filling levels of tank. In a high filling level, we have accepted some assumptions. The constancy of the volume of cargo, constancy of vessel pressure, and change of hydrodynamic impact in high filling levels we have calculated as a linear. We calculate on the next formula. Then we have considered low filling levels of the tank, and here we are reviewed as a hydraulic hammer on the bulkhead transfers and calculated on the next formula. You can see on the slide. Calculation results show us that then we, by computer modeling, by SolidWorks simulation, we convert this pressure into the strength. And you can see in case of incomplete filling of the tank, strength is exceed allowable values. And in this case, it's essential to decrease loads on the tank or execute some design change of the tank and or maybe reinforce the tank in the impact areas. And we propose to create some chamfers, such this is a standard form and this is proposed tank form, and we have calculated the have executed strength analysis for another tank form, and computer modeling was executed by SolidWorks simulation based on finite element method, and we have calculated different angles of membrane. And you can see on the graph if change of angle and change of strength. And in the case of angle of 20 degrees, we have allowable strength about 112 MPa. The yield strength for in VAR is 276 MPa. Some conclusions. For membrane tanks was calculated strength prediction for different filling levels. Low filling levels may destroy primary membrane. To avoid risk of insulation failure cargo losses, we propose some change in the tank design and uses improvements stress that exceed allowable values. So.
Questions?
I have a question. So I don't know anything about tanks, but I always assumed that there would be sort of a mash in the tank in order to avoid fluid from sloshing to which then sort of limit the maximum velocity or mass that could move in a particular time.
Excuse me, you propose to create what?
Like if you have meshes in the tank?
Yes, but there's another concept of tanks. Yes, the prismatic type of tanks exist, but they are not used in LNG transportation, only 2 vessels we have with this type. But the most common using types is a membrane and the spherical type. And I don't know, maybe it's a construction easily for construct and terms, maybe something like
More questions? Okay, let's
Thank you.
Vystupení.